spades, and the 7 of spades is what happened. So it wasn't like she had skill. It was, and that's when we say something was lucky. She had a very small chance, and yet it happened. So today we're going to discuss sample space. So when Lainey won that, and it was like such a big deal, because why? What was the last thing that we did in the last class that we had? Bunger?
We did the likeliness. So if it was half, it would be as likely as not. So we did all the likelinesses, and we saw the cards. It was really close to impossible.
So when we use, let's start easy. When we use our die, how many options are there when I use this die? 6, right? So when you are trying to make your choice, you have one option out of 6 total. Now when we switch and we come to a deck of cards, how many options do we have there? 52, right? So that's why it was such a big deal. What you guys are just talking about is everything that we deal with today.
So, I do what exactly?
You just throw the dart, and if you hit a composite number, I get a point, and if you hit a prime number, you get a point.
Oh, okay. Ah, so now what?
Let's try again.
So you got all this annoying friend, right? Prime versus composite. Which of these numbers up there were prime, and it's on your paper still. Which of those numbers are prime and which are composite? Well, let's just look for the easy ones first. Which ones do you know are composite? 64 and 48, right? Those are even. They're, of course, composite. Is 57 prime? Is it divisible by 3? Yeah. Remember, 60 is divisible by 3. So 57 is also divisible by 3. What about 91? 91 is a prime number, so that's our only prime number. So let's think about these rules again. So I get a point when the dart hits a composite. So your friend says I get a point when it hits a composite. You will get a point when it hits a prime. So actually I have this highlighted incorrectly. If we're going to say prime is green, I'm going to highlight the prime with green. Is this fair?
No.
Why is it not fair? Like, what do we even mean when we say fair? Katie?
There's only one prime.
Well, how many possible areas are there for your dart to land? 4. So this is not fair because my prime value there is only 1 out of the 4 options, whereas my composite options are 3 out of the 4. She has a much higher chance of winning a point than you do. So this is not fair because in the sample space, the outcomes, prime versus composite, do not have an even likelihood. So when we talk about probability or likelihood of something happening, we always have an action that we're performing, a sample space that action happens in, and in is not like physically like inside of something, it's kind of like metaphorically in a way. And then we have the outcome that we are looking for, or the outcomes that we're anticipating, or something. So like when you were trying to guess what number was coming up on the die, how big was our sample space? 6, right? Because we have the outcomes 1, 2, 3, 4, 5, and 6. Those are my possible outcomes. When you were looking for a certain number, that was the outcome that you wanted, and the action was rolling, right? So our action, if you want to highlight with me, our action is the roll. Let's say we're looking for a 3. So one of our possible results is a 3. That's the outcome that we're looking for. And my sample space is 6. So the probability of rolling that 3, what's the probability of rolling a 3? 1 out of 6, right? So my probability of a 3 equals 1 out of 6. So we always say P and then parentheses, whatever outcome we're looking for. So probability of a 3 is 1 out of 6. So here's my sample space. Probability allows you to analyze actions, so this is just telling me what probability is. So my action is choosing a button. These are all buttons. Your black and white copy kind of does not do this great justice. So outcome is each possible result. Sample space is everything that I see. And my event is when I choose. So we want to determine what's the probability of choosing a white button. So down here below, probability of choosing white. How many white buttons do I have? 4, right? They're these that are circled. How many total buttons do I have? 10. The biggest mistake I see people make. In the denominator, they will try to put how many not white buttons there are instead of putting their total. So remember, it's always part over whole. So always what you're looking for over the total. So what would this be as a decimal? 0.4 or 4/10. And then as a percent, you have a 40% chance of selecting a white button. Any questions at this point? So now we can look at different outcomes and analyze probabilities versus each other. So we already saw rolling a 3 has a probability of 1/2. Or sorry, getting ahead of myself, 1/6. But if we wanted to look at rolling an even number, now my even numbers are 2 or 4 or 6. So what's my probability of an even? Yeah, it's 1/2 because it's really 3 out of 6, but we always want to reduce our probability to simplest form, so it is really 1/2. That box looks kind of bad. So 3 of the outcomes are what I want. There are 6 total possible outcomes. So, this is for you guys now. Band director chooses one trumpet player at random to lead the band in the holiday parade. List all the outcomes in the sample space for this action. How many outcomes are in the sample space? So the action was choosing a trumpet player to lead the band. So what was the sample space? You have to think about what group was the choice made from, and then how many outcomes in the sample space. So I'm going to pop back over to Realize really quick. I think this is part 2. Charge. No, you guys don't know that?
Yeah, I know.
So, here's our trumpet players. James, Jenny, Raul, Seth, Sarah, Maria, Jenny, and Julia. Or Julie, sorry. Sorry, Julie. So what is my sample space? What is the group that I'm making the choice from? Bella? The trumpet players. So my sample space is the trumpet. My sample space is just the trumpet players. How many outcomes are there possible in the sample space? 8, because there are 8 trumpet players. So the probability of Jenny or any one of them being chosen would be 1/8. Any questions on this? Analyzing what your sample space is. Could a percussionist be chosen to lead the parade? No, that's why our sample space is limited to only the trumpet players. Now, if it said they choose a member of the band to go represent the band, that would be different. That would change your sample space. So, what is the sample space for this action? And then how many options are there? So it's easy to say how many options are, but what is my sample space? Eli? So, normally in your action statement, you can kind of figure out a little bit about your sample space. So our sample space here, what's on the spinner?
Numbers.
So our sample space is the numbers on the spinner. Because there could be situations where there's numbers and letters, or numbers and shapes. Or so you can't just say the spinner. We want to say what it is that's on the spinner. Then when we say how many outcomes, and this goofs people up.
It's 10.
Why is it 10? I only see numbers up to 9.
There's 0.
0 has to be a counted number. And since you normally start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, when we count 0, we actually have 10 possible outcomes. You could also just think of 0 as if it was 10.
That's what I always do.
Somebody has my 10 spinner. They were trying to make a game. Okay, make sure you don't lose that, because I do need that back. And actually, if you could bring it to class Friday, we might do a little lab activity. General note, now that we're gonna, by the time you come to my class Friday, you'll be done with all your state testing for me. Class gets a little bit more relaxed because we don't have like a pace that we have to move at. So we'll probably do more activities. I'm gonna try to get us outside some. I'm gonna try to utilize the outdoor classroom. So hang on to your seats. We've got a month of school left. It'll be good. Yeah. Maybe with going out there when there's a blocked class, that's a lot of kids to try to keep track of. So that's the only thing that makes me nervous, taking the whole group out there. But we might.
Who are we blocking
Actually, I think I just figured out what we should do on Friday.
What?
A couple things, but also I should introduce the egg drop project. Since we'll be blocked and have both classes together.
If you could, that would be cool if you could block the science, but it's...
The schedule doesn't work. Yeah, that's what it stinks. But we might be able to just like make it like,
Yeah, just
because it's end of the year, we might be able to like force some changes. We talked about this because this was out of order. We talked about this. Oh, so hold up. Now we've got specific events. So now thinking back to the same situation, I don't think this is on your paper, so don't worry about this. We have two different events that we're looking for to analyze the probability. First event is what is the chance that I will choose a boy? Second event is a person wearing a striped shirt. So when we look at how many boys are possible up here, Seth, Raul, and James, right? So how many times that event occurs is 3. What again was my sample space? 8. So it's 3/8, which actually comes out to be, anyone know? It's going to be a 4th plus another 8th. 0.375. Because remember, a 4th is 25%. An 8th is 12.5% or 0.125. So this really comes out to be 37.5%. Now what about a person wearing a striped shirt? Who's wearing striped shirts? Raul and Sarah, right? So what's that event probability? 2 out of 8. What's that reduced to? 1 out of 4. What's that turn into? 25%, which I will take the long way to get to and show the decimal first. Is this making sense? Any questions, comments, concerns? Nope. Let's try this on your own. We have a spinner. What is the probability that the event, the spinner stopping on an odd number, will happen? Well, first off, determine what numbers make that event happen. Well, I see a 1, it's odd. I see a 3, that's odd. I see a 5, that's odd. I see a 7, that's odd. And I see a 9, that's odd. Is 0 odd or even? So there's arguments on both sides. There's an argument that it's even because when divided by itself, people argue it becomes 1. But the other argument is you can't divide by 0, so you can't divide it by itself. So it it wasn't the division by itself. It was the division by 2 still comes out to be an even number, but it would be 0. So if we accept that 0 is even, then 0 divided by 2 makes an even number. It makes 0. But if it's not even, then that doesn't work and it falls apart. So regardless, it's not odd. There's arguments on whether it's even or whether it's neither. Some people say it's neither. It's not even or odd because it's not countable. You can't count 0 objects. You can not
What's
count them.
infinity then?
It's neither. Infinity is not even a number. It's not a tangible number.
Well,
No, it's an
no,
idea.
there's
It's like a
there's
concept.
different infinities though.
But infinity is a concept. It's really not a it's not a tangible object. Like 9,472,000, that's a tangible object. So 0 is not included in the event that I want. We have so we would say the probability of an odd. So everyone write P of odd. We say that P of, when it's in parentheses, probability of. What's it start with? Yeah, do not immediately reduce. Start with what it is. So it's 5 options, 5 odd options out of my 10 total options. Then I can reduce it, and then I can convert it. And if you know how to go straight from your fraction to your percent, you can. Otherwise, show the decimal first. By the way, the yellow calculators, the new multi-view ones, do fractions a whole lot better than the old ones. So if you like being able to type a fraction in your calculator, use the multi-views, which you can always use. I just keep them locked up because we have to keep track of them. So if you want to borrow one, it has to stay in this space. So write a verbal description of this event. The action is 1 spin of the spinner. The event that we're looking for is 3, 6, or 9. So how would you describe those event outcomes? Could you make one statement to say the event we're looking for? Because I want to know what could I fill in inside my parentheses. I could obviously fill in 3, 6, 9, but I want a verbal descriptor. Well, we could say every third number, but then we'd have to say starting at 3, and that gets kind of annoying. That would work, but it's just not very efficient. Emma? Multiples of 3. 3, 6, and 9 are all multiples of 3. So what's the probability of getting a multiple of 3? So the same spinner is on your paper, so you can still think it through. Like, I don't ever want to make more than a page of copies. That makes me upset. I really am thinking about next year trying to have them bind these, like do a unit at a time, like 3 or 4 chapters, and you can get them bound or like at least stapled together and whole punch. So I'm trying to like make my own books essentially. But it took me a couple years to get there. So how many outcomes satisfy what I'm looking for? Thomas?
3 out of the 10 outcomes.
Yeah, 3. They listed all of the outcomes right here. I know that there's 3 that are my multiples of 3, 3, 6, and 9. So that's 3 out of all my 10 outcomes. This comes out to be a 30% chance. So they also say a number divisible by 3, which is the same thing as saying a multiple of 3. That's also why we should be able to get to the next section today as well. and then I'll be able to just give you guys more time to work. So think about action, sample space, and event that we're looking for. Using cards on this one. So you're telling me, is it the action, the sample space, or the event we're looking for the spinner or for the number cube? Essentially, that's a die, but they say number cube because die uses dots instead of numbers. So, Bela, what do you think? 1, 2, 3, 4, 5, 6. So I'm looking for 1, 2, 3, 4, 5, or 6. That's the outcome that I'm looking for. Yeah, this is my entire sample space because that's all of my options that could happen there. So go ahead and fill that in for sample space under the number cube. Isaiah, what about roll a number less than 3? Yeah.
Die.
Yeah, it's the event for the number cube because this descriptor of less than 3 tells me what I'm looking for, which makes it the event. Eminol, what about blue, red, green? Yeah, for the spinner, right? That's all my possible outcomes for the spinner. And you can abbreviate BRG if you want. Cassidy, what about spin the spinner? Yeah, that's the action we're going to take. Is that for the number cube or the spinner?
Oh, for the spinner.
Yeah, right. That's kind of obvious. Crystal, what about roll a number cube? Yeah. You could also just say roll. Your action will be to roll. If we had a deck of cards, your action would be to draw. If we had a spinner, your action is to spin. Ethan, what about the spinner stops on blue?
Well, obviously, it's the spinner event.
Process of elimination tells me that's the spinner of event. So, on your got it there, I want you guys to, under each of those options, notate whether it is the action, sample space, or the event that occurs. So whether it's the action, the sample space, or the event that occurs. I'll give you about 30 seconds because I don't think we need very long. What do you think, Abby? Which of these is, let's just start with the broad, which of these is our sample space? Yeah. When we, like the sample space is always listing all of the possible outcomes. So when we are playing a game, you could win, lose, or tie. This is your sample space. One of these will happen. Zach, what is my, let's say what is the action?
Play the game.
Yeah, playing the game is the action that will happen. And then obviously the event or the outcome that we're looking for would be winning the game. I want to know what's my probability of winning the game in that sample space of win, lose, tie. And if you say that you and your opponent are evenly matched, that gets kind of complicated because to say what's your probability if you and your opponent are evenly matched, well then what's the probability of a tie versus what's your probability of winning and losing? So what if I tell you that your